Hi everybody, this is Mr. Nolan, and what I would like to do with you in this video is to talk about dichotomous keys. So by the time that you watch this video, you should be able to use a dichotomous key to identify an object based on its traits. Now the example that I'm going to give you in this video is rocks. You can apply this logic that I'm going to show you to any dichotomous key. You can even create your own dichotomous key if you know the features and if you understand the logic of a dichotomous key. Now don't be freaked out by this term dichotomous. All that dichotomous means, you'll notice it's got that little di in there, which means two. A dichotomous key is a tool that you use to identify what an object is. What would you call it? By answering a series of yes and no questions. And so every time that you answer a question, you're either going to go to the yes side or to the no side. These are very, very useful because this way you don't have to memorize all the characteristics of your object. You can just use your key to just follow the path. And once you hit a dead end, you know that's your object. So dichotomous key that's a tool. Yes and no questions. The key to using the dichotomous key is that you have to answer the questions correctly every time. If you mess up even one question, you're going to show up in the wrong place. You're going to end up with the wrong object. So let's look at a few examples here. I'll do as many in this video as I have time for. So this is an example of a dichotomous key. I don't know if you can see it very well in your video or not, but I've included a link to my website. This is not a perfect key. No dichotomous key is actually absolutely comprehensive or absolutely perfect. And actually, based on some of the issues that I noticed, I added a few little notes here in these little purple boxes, just so that it helps us a little bit with telling these things apart. So in my dichotomous key that I made for identifying rocks, what we are being asked are these yes and no questions. And so what we're going to be doing is I'm going to be showing you a variety of different rocks and trying to use our key to tell them apart. So to start off with, let's use this example and I'll show you how a dichotomous key works. So this example is kind of white, it's sort of heavy, it's weighty, but if you see on the dichotomous key, the first question that it asks is, does the sample fizz with acid? So that's the first thing that we're going to test here. We're going to see, does the sample fizz with acid? So I've got this sample, I'm going to put a little drop on it here, and I don't know whether you can see that or not, but it's actually effervescing, so there's some fizz that's being formed there. You might see the little sort of mist or smoke that's sort of coming off of that. And so we would say, yes, this effervesces, this fizzes when you put acid on it. And so what that means, because the answer is yes, we're going to take a left here. So we're going to say, all right, we're going to go left. And now we just have to tell, well, are there particles of shell or sediment, or are there not? Well, if we look really closely at this, I don't see any actual pieces of shell or pieces of sediment. Do you? So I would say no. So in answer to this question, are there particles of shell or sediment? No. So we're going to take a right. And what we're left with is marble. And so as long as we use the key correctly and we answer our questions right, this should be marble. We can be pretty reasonably certain that this is marble. And I put a little note here. Marble is harder than limestone. So if you're looking at two different samples and you're wondering, well, how do I tell these apart? Both of these fizz when I put acid on them. Well, this one's a lot harder. So this is probably marble. And if you look really closely at this one, it's actually got tiny little particles in it. And so we'd say, well, this one is limestone, this one is marble. And I used our dichotomous key in order to figure that out. So let's look at another example. Let's look at a really neat one. So here's another example that you might be able to see on your screen. It's very shiny. And so in answer to our question, does the sample fizz with acid? Well, let's go ahead and see. Put a little drop on there. And I don't know if you can see it or not, but I don't see any fizzing. I don't see any drips or any fizzes going on there. So I'm kind of just going to shake that off. So we would say no, this is not fizzing when we put acid on it. So we're going to take a right here where it says no. The next question is, do we observe grains? Are there grains observed? Well, if you look at this, does it look like, can you see little particles? Are there grains, or is it just like one big chunk? I think I just see one big chunk. And so I would say no, that we really do not observe grains here. So what that means, we're going to take a right, and it says no, grains are not observed. So now the question is it glassy? Well, I would certainly call that glassy, right? So we're going to take a left because it says yes, and we've arrived at our rock. If it doesn't fizz with acid, if you do not observe grains, and if it is glassy, that means that it must be obsidian. Whereas with our marble, it fizzes with acid, and we don't see particles of sediment. It's also harder than limestone. That means that it's marble. Okay, so this would be obsidian. Let's look at a rock that's actually kind of similar to obsidian, and we're going to try to figure out, well, can we tell this rock apart from obsidian based on its characteristics? So if we're going to take our rock, we're going to take a little bit of acid. That's our first question. I'm going to put a little drop of acid on it, and I do not see any fizzing. I don't know if you do, but I don't see any fizzing on there. So we're going to take a right, and this rock, we're going to take a right for no. Do we observe grains? Well, if we look really closely, they are there, and they're actually easier to see on the outside of the rock. There are grains here. They're very, very, very fine. They're very small. So we're going to take a left. Yes, we do observe some grains. Are the grains sediment, such as sand or cobble? I'll just tell you, the answer is no. One of the ways that we know this is that it's not gritty. It's not gritty. It's also not very smooth. It's just kind of jaggedly broken. And so when we look really carefully at this, we do see that there are grains, but the grains are really, they're not sediment. They're actually very small crystals. So what that means, in response to the question, grains appear to be sediment, we're going to say no. So we're going to take a right. This is asking, grains appear in layers or bands. I don't see any layers or bands in there, so we're going to take another right and say no. Grains are large crystals. Did we say those were large crystals or small? We said these were small crystals, so we're going to take another right. And according to our dichotomous key, we end at basalt, and that would be correct. This is basalt. This is igneous rock where the crystals formed very quickly, and so they're very small. And so there's another example. Let's look at a couple of others. Here's a really good one. I always like these rocks. This is a really rough-feeling rock. Let's see what happens if we put a little drip of acid on it. I do not see any fizzing. I don't see anything going on there. So we would say, in response to our question of does it fizz, we would say no. So we're going to take a right. So we know it's not limestone or marble. So we're going to take a no. Are grains observed? So this does not fizz with acid, and so we know that it's not limestone or marble. So we're going to take a right here. Are there grains observed? Yes, we can feel them. We can actually feel these grains. It's very gritty. So we're going to say yes, we can feel the grains. Would we say that they are sediment, or are they crystals? Well, if we look really closely, and if we feel it, there's really no crystals here. We don't see crystals, not in the way that we see them here, right? These are crystals, right? We can see some really nice crystals here. This one doesn't have crystals. It's actually got really fine, it feels like sand. So the grains appear to be sediment? Yes. So we're going to take a left. The question now is, are the grains cobbles? Well, these aren't cobbles. These are just sandy, so it's sort of sandy. So we're going to take a no. We're going to say no. That means this must be sandstone. If it feels like sand, looks like sand, it's sandstone. Let's keep going. Let's look at a few other examples. Here's one that's kind of related to sandstone. If we were to answer all the questions, we would find no, it doesn't fizz. Yes, there are grains observed. Yes, the grains appear to be sediment. But now when we show up down here, if in the question, are the grains cobbles, we would say yes, the grains are cobbles, which means that we would call this conglomerate. Cobbles is just another word for like pebbles or little chunks of broken rock. Let's keep going. Let's look at some others. Here's a really nice one. These are very, very pretty. So this is a rock that has these very clearly distinguishable crystals. We can tell right away. So let's go ahead and put a little drop of acid on there. And as I put my acid on it, I don't know if you can see it there, but the acid is not fizzing. So we're going to say no, the acid is not fizzing, so we're going to take a right. Are grains observed? We would say yes. So crystals count as grains. A grain just means that you can tell little bits of color apart or that you can feel them, one or the other. So we're going to say yes, grains are observed. The grains appear to be sediment or sand, cobble, no. These are crystals, so this is not sediment, so we're going to take a no. The grains are arranged in layers or bands. You know, I would not say so. I don't think that there's layers or bands here. It's just chunks of crystals, so we're going to take a no. Grains are large crystals. Yes, they are. They're not small. These are large crystals, so we're going to say yes. And now the question is, are the crystals pale colored? I would call these pale colored. So we're going to take a yes, and we end up at granite. This is a textbook beautiful version of granite. Let's keep on going. Let's look at a few others. Here's a really nice one, a good example. It's small, but it's a good example. Let's see if it fizzes with acid. We'll drop there. I don't see any fizzing going on, so we would say that no, it does not fizz with acid, so we're going to take a right. Are grains observed? Actually, no. It's very smooth. It's fine. It's very smooth, so we would say no. Now, in response to the question, does it have a glassy texture? Well, we saw with obsidian, obsidian has this really shiny, beautiful, glassy texture. And so we would say no, this actually does not have a glassy texture. So we would say that it's shale. And the big indicator that it's shale and not basalt is that look at how they break. Look at how this is a flat little sheet. This is a really clear-cut indicator that it's probably sedimentary. It's also rather soft. You can basically just break off little bits with your fingers, but the basalt is rather hard. There's no way you'd be able to just break off chunks of basalt with your fingers unless it was actually rotten rock, if it broke apart, which does happen. You can run into kind of rotted, crunched up rocks that are friable. You can break them with your fingers. But we would call this shale because it's not glassy like obsidian. It's also flat. It comes in sort of these little flakes, so we would say this would be basalt, but this is shale. It forms in these little flat pieces. Let's keep going. I got about 4 more minutes with you. Here's some great ones. Oh, these are beautiful. So let's take a look at these. I'll go through these 3 examples. These 3 examples are what I will finish with. Here's a really nice one. Or I shouldn't say it's really nice, but it's a good example. So this one has got some little tiny crystals in there. They're rather small. And so I'm going to go ahead and use my drop here. We see that there's no response to the acid. It is not fizzing. So we're in response to the question of does it fizz, we're going to say no. Are grains observed? Yes. Those little glittering crystals, those are grains. So we're going to say yes. Do the grains appear to be sediment, like sand or cobble? No, they are not. Anytime you see this really pretty glittering, I know it might be hard to see on your screen, but you'll see these little flashes and glints of glitter. That's not sand or sediment. We're going to say that's something else. Those are crystals. So we're going to say no, the grains don't appear to be sediment. They appear to be crystals. So the grains arranged in layers or bands. Well, let's look really closely at this. I don't know if you can see it on your screen, but there's some faint banding going left and right on this. It's hard to spot, but there's a little bit of banding. So we're actually going to say yes. So now we've got a choice here. We've got a choice of all these different rocks. It's either quartzite, slate, schist, or gneiss. And for each of those, I give a little description. Well, if we read these descriptions, what we'll find is that schist has lustrous, glittering grains. However, I don't really see distinct light and dark bands. I see very, very faint bands, but they're not really that distinct. So we're going to say that this is schist. Schist is kind of like a low-grade metamorphic rock. And metamorphic, just to remind you, metamorphic means that the rock has been squished. It's been pressed. So schist is metamorphic. It's those little fine glitters. That's the indicator that you're looking at a metamorphic rock which is not marble. Because remember, marble doesn't have those nice pretty little glitters in it. But this schist would be a good example that does. Let's look at another example. This one is a beautiful example of another glittery, pretty rock. So let's go ahead and take a drop of acid. We find that it does not react, so we can see that our acid is not reacting with this rock. So no, it does not fizz in response to acid. Are there grains observed? Yes, very clearly. Those are crystals. So we would say yes, the grains are observed, and they are not sediment, they're crystals, so no. The grains are arranged in layers or bands. Well, let's look. Do you see any layers or bands there on that surface? Maybe what about this one? Do you see any layers or bands? They might be kind of hard to see, but I would argue yes. You can actually see some banding, some dark bands and some light bands. Okay, let's take a left for yes. There's bands here. And now we're in the same place that we just were when we were trying to figure out the schist. We have a much more glittering crystals. So if we look at these 4 different rocks, we would say that this is gneiss. We have dark and light glittering bands. So these crystals have been squashed, and that's why they're so bright and glittery and pretty. One more example. I'll blast through this one really quick. This is a rock that's kind of whitish. I put acid on it and it has no response, so no. Yes, there are grains that are observed. They're these huge chunky crystals, so yes. No, they are not sediments, so we're going to say no. This is not arranged in bands or layers. However, I added a little note here that quartzite is pale hard rock that forms without layers, and so we would call this quartzite. So I hope that this video was helpful in helping you to find out how do you use a dichotomous key to identify an object such as a rock based on its traits.